Hi, my name is Fred Tingey and I'm one of the founders of DeQuantifi, and today we're going to take a quick look at VaR analysis for crypto derivatives, including options. In this video we will see how DQTools, our crypto analytics library, can facilitate and simplify the construction of custom reports such as historic VaR. In order to calculate historic VaR, we need to get access to historic crypto price data, including futures and historic implied volatilities. With that historical data set, we need to be able to infer daily price and volatility movements for any given token and scenario date. Then we will need to load a set of our positions and current market data to get a baseline P&L. The penultimate step is to apply all of our historic price and vol shifts to our current market data set, revalue the portfolio, and figure out the change in P&L for each scenario. Finally, from the distribution of P&L changes, we can pick out the 95% confidence level VaR figure, and while we're at it, we might as well calculate the expected shortfall as well. At DeQuantifi, we have access to historical price data, and in DQTools, we have a handy class for loading data bundles. Here, we will load up around 1,000 days worth of historic data from Deribit. We can take a look at the history, which covers price changes for swaps and futures. To deal with derivatives, instead of looking at the individual price changes, we need to work instead with the futures curve as a whole. DQTools provides a handy class for that, the futures curve data bundle, that converts price changes into curve changes, as you can see here. For the VaR analysis, we need to be able to apply the historic curve shifts to our current market data set. And we do this by multiplying the historic curve shift as a percentage change to our current futures curve. For volatility, we have a similar situation in that DQTools provides a volatility data bundle with historic implied vol data, along with a vol surface data bundle to assist with the construction of historic vol surfaces. Now, volatility is a little bit more complicated because not only do we need to deal with the time to expiry, we also have to deal with the strike, which we handle as a percentage spot figure. Here we can see the change in volatility surface for the Bitcoin vol for a single scenario. Moving on to the current positions, that's really easy with DQTools. We have these exchange data reader and market data reader classes to do that for us. And we can combine those in the valuation object to get direct access to our portfolio and the P&L, risk figures, etc. This portfolio contained Deribit positions only, but DQTools covers multiple exchanges. Here we can see we have some options and some futures and some other products. The valuation object gives us direct access to the overall P&L for the portfolio as a whole, which we will need as the baseline for our VaR analysis. So, to recap, we have seen the futures curve data bundle from which we can get the future curve scenario shifts, and we have seen the vol surface data bundle from which we can get the implied volatility surface shifts. We also have a valuation object that gives us the portfolio P&L, and we have the baseline P&L for the VaR calculation. Now, to actually calculate VaR, we need to be able to apply our historic shifts to the current live market data set and build up a distribution of 1,000 or so P&L impacts from those scenarios. To do that, I have a couple of helper functions. The first to calculate for each scenario what shifts to apply, and the second to actually apply those shifts to our market data set. The gather shifts function iterates through our portfolio and interpolates what changes to the future curve need to be applied and what changes to the vol surface need to be applied. The delta P&L function will iterate through the different market data tokens that we have and gather and apply the market data shifts for each scenario date. It then returns the actual change in P&L because of that scenario. We take advantage of pandas to apply our delta P&L function to all the scenarios that we have. And then we can take a look at the changes in P&L for each scenario that we get. Plotting those results as a simple graph, we can see the change in P&L for each of the scenario dates. It goes up, down, hovers around 0. And a slightly better way to look at that is as a histogram. What we do is we pluck the VaR figure out of the 5% worst P&L impact figure. Now, we also calculate expected shortfall, and the way expected shortfall is calculated is by taking the average of not just the red box, but also all the green boxes. And this helps to take into account any fat tails or outliers in the distribution. So we end up with an expected shortfall of about $600, and we had a VaR figure of about $380. Using DQTools can save you a lot of time and effort when creating custom analytics and reports for crypto derivatives. If you would like to find out more about our library and the custom reporting services we can provide, please contact us at DeQuantifi.com.